Hello and welcome. In this second part of a three-part series of videos on building a weather station with a Raspberry Pi, I'm going to be going over making the code base more modular. In addition, I'll be adding environment variables to the program to make it easier to configure for different hardware configurations. Lastly, I'll be introducing logging into the program so that it logs any errors to a log file to help with making diagnosing issues easier. As always, if you get value from this video, please give it a thumbs up and click the subscribe button. With that said, let's crack on. To start, rename the main.py file to main-part-1.py and create a new file named main.py. The reason for this is due to the number of changes that will be made. It will be easier to start with a new file, but a good amount of what was done in part 1 will be used again. Next, create a new folder called modules at the root of the project folder. In that folder, create 4 new folders called displays, env, login, and sensors. Next, in each of the 4 folders, create a file named __init__.py. Close each file when they open, as there will be no changes to be made to them. These files are used by Python to indicate that the folder contains a module. With the folders created, let's get started with building the first module. The first module that will need to be set up is the login module. This will allow the program to record any errors that are encountered in the program to a file, so that in the event of an error occurring, it can be used to diagnose what caused the error and why. First, create a new file in the login folder called log_config.py and open it if it doesn't do so automatically. I'm just going to collapse these folders to make it a little bit easier to work with. I'm just going to paste the code in. Now, let's review what was put into this file. First, there's the modules that need to be imported for this module to work. So we've got login and OS. Next, there is a function called load_login. In that function, it will create a variable called log_folder_path that points to a folder in the root of the project called logs. After that, if the logs folder does not exist, it will be created. Then, a variable called log_file is defined for the location along with the name of the log file to use. Lastly, we define the settings for the login. These include where to store the log, so we're going to use log_file, the encoding, so we're going to use UTF-8, the log level to start at, in this case login.error, so anything that is an error or above, which would be critical, would be logged. And then we have the format for each log entry that would appear in the file. In this case, we have the log level, so that's level name. Then we have the date and time, so ASC time. Then we have the name of the module that caused the error, and then what the actual error is. So now I'll save the file, and that can be closed. That completes the setup of the login module. Let's move on to creating the environment variables module. Before we get started with writing the code for this module, there's an additional library that needs to be installed called python-.env. This is used to create environment variables from within a Python program. To install it, run pip3 install python-.env. I'll just clear that terminal, and I'm going to collapse the login folder. Next, in the env folder, create a new file called .env. This file will contain the environment variables that will be used in the program. If the file didn't open automatically, just open it and put the following code in. There are 4 environment variables listed. They're all pretty much self-explanatory in how they're named, but to go over them briefly, we've got output to console is true, LCD screen connected is true, LCD screen type is 20 by 4, and ENV sensor type is BME280. These will just be used later on to define what actual configuration we want for the hardware to be used in some of the other modules in the program. Save that file and close it. Next, create a new file called env_vars.py. Again, if the file doesn't open automatically, just open it. I'm going to put the code into that. So let's review what code was put into the file. First, we've got the modules that need to be imported for this module. Then there is a variable called log that will be used to interact with the logger that is running. The logger will be set up later on in main.py. After that, there's a function called load_env_vars. This will be called when the program runs to set up all the environment variables in the .env file. In this function, it'll attempt to load the environment variables. That's this block here. And if it can't, it will write an error to the log file and exit the program. If the environment variables do get loaded, it will then check one to see if it loaded and if it has a value. If that value is none, again, a log entry will be created and the program will close. So I'll save the file and close it. That covers setting up the environment variables module. Next up, the sensors module. The sensors module will be a little bit different from the previous two, in that it has 2 functions in the file rather than just one. I'll add each function one by one and then go over them. To start with, create a new file in the sensors folder called sensors.py. Just collapse that env folder first. Now just put the code into that file. Okay, let's review what was put in that file. First, there's the libraries and the modules needed for the contents of the file, along with the log variable again. Then we've got our first function. The purpose of this one is to initialize the sensor and return an object with all the settings to work with the sensor back to the caller. Most of the code you may remember seeing in part 1, as it's mostly the same, but to summarize it, the first try block here will attempt to initialize the I2C interface on Raspberry Pi. If it can't, it'll write an error to the log and exit the program. Going down a bit, we have a second try block, and what that will do is it will attempt to initialize the sensor board on the I2C interface. If it can't, it will write an error to the log file and exit the program. If all goes well and the sensor gets initialized, it will then set the sea level pressure to whatever number is set, and then lastly, it will return the sensor object back to the caller. So that's the first function in that module. I'm just going to put some empty lines on, and I'm going to put in the second function. This final sensor function, named get_readings, is very simple in that it will take a sensor object as an argument and uses that to get the readings from the sensor board. The readings are stored in a dictionary and that is returned to the caller. If for whatever reason it can't get the readings, such as a defective sensor board, it will write an error to the log file and exit the program. Let's save the file, close it, and that's that one done. Now it's time to move on to the displays module. With the login, environment variables, and sensors modules set up, the last module to create is the displays module. Just as before in the sensors module, there will be multiple functions. Again, I'll add them one at a time and go over each one. First, you need to create a new file in the displays folder called config.json and then open it if it doesn't. I'll just collapse sensors first. And I'll just put some code into it. The purpose of this file is to list the settings for each of the display sizes. As you can see, there is an entry for a 20 by 4 screen and another for a 16 by 2, with each having the relevant settings for that screen. So we can see what the expander type is, the address, port, columns, rows, and dot size, pretty much as was done in part 1. So I'm just going to save that file and close it. We're not going to make any more changes to that. Next, create a new file in the displays folder called displays.py. Just going to put the code in. Okay, so let's go over what I've just put in there. We've got our usual imports. We've also got one for JSON as well. We then have our log again, so we get the current logger. Scroll down a bit. We have a variable called config_file_path. And what that's used for is to determine the actual path of where this file currently is, and then append config.json at the end of it. After that, in this if statement here, it'll check to see if that config.json file exists in that path. If it doesn't, it'll just log an error and then raise an exception and exit the program. If that file is present, then it will then load that file and then put it into a variable called config. Next, we have a variable called screen size, which will then use an environment variable that was set previously called lcd_screen_type. That will just come back as either, presently at least anyway, either 20 by 4 or 16 by 2. It could be something else, but if it is, it'll break the program. Next up, what we want to do is check to see if the screen type that's listed actually matches one of the config keys in config.json. That would be either 20 by 4 or 16 by 2. If it matches, it will then try to initialize the display and create a config for it, and that'll be assigned to a variable called LCD. If it can't, well, it's going to do what everything else does and just raise an error. Now, there's two possibilities, but these are the same ones that we had previously in part 1, so this is just reusing old code. Now, if in the event that it can't match that display type to one that's in the config.json file, then it will basically log an error and then exit, as indicating that there's not an entry available for it or it can't find the screen. And lastly, it'll return the LCD object back to whatever called it. Let's save that file and then just put a few lines between it. And then I'm going to copy the last two functions. Now, I said I was only going to do one at a time, but these two functions are very similar in what they do, so I'll just go over both of them quickly. So the first one of the two that I've just pasted in is called output_to_LCD. It takes two arguments, the first one being the readings from the sensor. That's a Python dictionary. And then a second, which is display, which is an object, which will effectively be what this is here, the LCD variable that was returned to whatever called it previously. If I scroll down, you may recognize this because this was basically what was in part 1. It'll just take those two arguments and then attempt to output to the display. It'll check what the display size is. So if it's 20 by 4, it'll do this block. If it's a 16 by 2, it'll do this block. If it's any other size, it'll just default to this, but it shouldn't actually do that because it should actually exit out of the app, out of the program. And then lastly, if the display can't be found because maybe it's become defective, then it'll just pretty much write an error to the log and then raise an exception and exit the program. And then the final function is called output_to_console. And that just takes the same readings that the previous one did, again as a dictionary, and then pretty much just outputs it to your terminal console. So now I'm just going to save the file, and then I'm going to close it down. And that's all the modules created. The next and final file we need to set up is the main.py file that will bring all the modules together and get the program working. With all the modules created, we're now onto the final file. First thing I'm going to do is just collapse the displays folder, and then I'm going to open main.py. This main.py file will basically control the flow of the program rather than have all the code implemented inside of it like we did in part 1. Instead, it will import the code from the modules and their functions that we've created previously. So I'm just going to paste in the code, just scroll to the top and just go through what we've got in this code base. So first up, we have the imports that pretty much we do in near enough every single one of these files so far. The difference with this one is, aside from some of the built-in Python libraries that we use and maybe some imported ones that we've installed, there is this section here which is used to basically import all of the modules that we've created. So modules.displays.displays effectively opens the modules folder, then opens the displays folder, then opens the displays file, and then imports our 3 functions that we created in that file. And the rest are basically the same. If I scroll down a bit, we have the main function itself. So the first thing it's going to do is run the load environment vars function that came from the env vars file. Then it's going to create a sensor object. And what it's then going to do is get the environment variable for LCD underscore screen underscore connected and check if the value is true. If it is, then that indicates that we're going to be using this with a screen attached, and it'll set output underscore to underscore LCD underscore required to true, so that I've got an actual real Boolean to play with. After that, it will then initialize the LCD screen and return back an initialized LCD object. Otherwise, it'll just set that same variable, constant, whatever you want to call it, to false, which means basically there's no screen required. And similarly, again, we've got an option to check output underscore to underscore console. And again, if we want the output to go to the console, then it gets set to true, assuming that one of these is matched. If not, set it to false and we'll get no output to the console. Next, we have a very simple if statement that'll just check to see if we need to put output to the LCD screen or to the console. If either of those are true, then what it will then do is run a while loop, first starting with getting the readings from the sensor. It will then check to see if the console output's required, and if it is, then it's set to true. Then it'll output to the console by calling the output to console function, and then again it'll do the same for the LCD screen, and then call the output to LCD screen function. After that, it will then sleep for 3 seconds. So pretty much basically what we did in part 1 is what happens here. I'm just going to save that. Now, if I run this file, nothing will happen. So I'll just try running it. As you see, nothing happened. And the reason for that is the main function is a function. It won't actually run until it's called. So we need to add some additional code to make that call to the main function for the program to run. So I'm just going to add some additional lines. Now I'm just going to add a little bit of code, which is just a simple if statement. This will check if the name is main, which it generally will be. If so, it will then call the load logging function. So this is where we initialize the logger. It will then get the logger and then attempt to run main. If it can run it, it'll run. If it can't, then it'll come back with basically what we always do, which is write an error to the log file and then exit the program. The difference this time is this comes back as a critical error instead of just an error. So in the log file, instead of saying error, it will just say critical. Because if it can't run main, then it's not going to do anything, in which case it's a very serious problem. I'm just going to save that file, and now I'm going to try and run it again. As you can see, we've got output to the console, and we've also got output to the LCD screen as well. In addition, we can now see that we've got a logs folder, and we've got an error log as well. Now the error log's empty because there's no errors. So what I'm going to do now is I'm just going to generate some errors by running a few things to effectively break the program, and then we should start seeing errors in this log file. Okay, so I've run the program a few times and I've introduced some intentional errors to get some entries added to the log file. So let's have a look at that. So as you can see, we've got a nice collection of errors. Well, that's open to interpretation. Ideally, I'd like no errors, but hey, that's life. So we can see that we've got a bunch of errors, and then we've got a couple of critical errors. Shows the date and time, what module caused the error, and what the actual error message was. So you see, unable to get readings from the sensor. When the program was running, basically I unplugged the sensor. Display could not be found. When the program was running, I unplugged the display. And the same error here, I ran the program with the display disconnected before it ran and came with the same error. And then no sensor board. Basically, I just did the same thing as I just did with the display. I unplugged it before I ran it. No environment variables were loaded. Tells me to check that the env file exists. I just renamed it. And the same for the config.json file. I just renamed that. And then unable to locate the main function. I just renamed the main function just to give an example of that error working. And these error messages can be customized to your heart's content. Do whatever you want with them, but ideally make them actually useful. Don't just put any old rubbish in. This completes part 2 of this project. There are a lot of changes to make from part 1, but I hope you can see that the program is much more modular, easier to switch between configurations using the .env and config.json files, and that the error logging will be useful for diagnosing any issues encountered. In the next part, I'm going to add a SQL database to the program so that all the readings can be stored for further analysis. This will be an additional module so that you can see the benefits of the code being modular. In addition, I'll be adding another program with a simple Python-based web server that will display the 10 most recent entries in the database and provide an option to download all the entries to a CSV file. Thanks for watching. If you liked the video, please like and subscribe, and I'll see you in the next video.